So you know by looking at the sideboard today that we are doing division, right? We're doing long division specifically, right? So is this division with polynomials? No. So why would I do this? What is this called? It's just called long division, right? So do you think there might have something to do with long division and polynomial long divisions, or something that they share in common? Yes. So let's go through this problem, and you'll see here in just a second what they have in common. Okay? If I'm doing this problem, what do I do first?
See how many times 6 goes into 2.
So how many times does 6 go into 2?
0.
I can't do that, right? So I need to step over 1. How many times does 6 go into 23? 3. Where do I write that 3? Above the 3, because I took it out of 23, right? So I multiply. 3 times 6. Where do I write that? Underneath it. And then I subtract. Okay? What is 23 minus 18? 5. Now that should be a number that can't be divided by that, right? So what do I need to do? I need to bring down the next term. How many times does 6 go into 55? 9 is 54, right? Okay, so write 9 up here, multiply 54, and then what? Subtract, right? And I get 1, and then I bring down my next term, 7. How many times does 6 go into 17? 2. And then I multiply, 6 times 2, 12, and then I subtract 5. And what is that? What's that called? It's called my remainder, right? So that's really the same as 5/6. Remainder of 5, but I was originally dividing by 6, right? Okay. So is this recalling any how to do long division? Okay, then let's do some polynomial long division. No, calm down. Calm down. You're getting too excited.
Of course there's a letter.
Yeah, of course there's a letter. You knew there'd be letters in it, didn't you? Because I said polynomial. What's polynomial? Many numbers or terms, right? Nomials means variables, letters, things like that, terms. Okay? Here's the deal, though. Before we said, on this one we said, how many times does this number go into this? We kind of do that, but we only look at the first term. I only look at those two terms. How many times does x go into x squared? Or what is x squared divided by x? Well, just as a reminder, x squared is the same as that, right? Divided by x. What's x divided by x? Anything divided by itself is 1, right? So that's just gone. What do I have left? So what is x squared divided by x? X. Where do you think it goes? Above the x term. It goes above the term that it's like. Right? Now what do you think we might do? Well, what would we do up here? Once we got the 3 up here, what do we do? I multiplied, right? I'm going to multiply x times x. X squared, I'm lining it up with the term that it's like. What's x times 2? 2x. What did I do up here then?
Whoa.
I subtracted, right? Subtracting is the same as what? Adding the opposite, right? 5 minus 2 is the same as 5 minus, plus a negative 2, isn't it? So while we are subtracting, we need to subtract every term. Does that make sense? We're kind of adding the opposite of what used to be there. We're subtracting each term. And that's why I need a different color, because I want to tell myself I'm subtracting both of these. Because really what I'm doing is changing the sign on each of them, aren't I? Okay, so what's x squared and a negative x squared? 0. Should this always be 0? Always? Yes. If it's not, you've done something wrong in your division. Because our whole purpose is to cancel out this term. Make it go to 0. Okay? What's 5x and negative 2x? 3x. Now what? Wait, have you done long division before? Polynomial long division? Then how'd you know to bring the 6 down? Oh, because it's like regular long division, isn't it? All right. Now go back here again. First term, first term. What's 3x divided by x? What's 3x divided by x? 3, right? 3. So it goes above the term that it's like. What do we do now? Multiply. What's 3 times x? 3x. 3 times 2? 6. Subtract both terms. 0. 0. Is there any remainder on this problem? No? So my answer is just x plus 3.
Okay, wait.
I'm waiting.
Confused, like, why did you put the x on top of 5x and not x squared?
So why did I put this x on top of 5x and not x squared? Because I want to line it up with the terms that it's like.
But, like,
X is like x. X is not like x squared. If I was adding, I couldn't add x squared and x, but I could add x and 5x. Good question.
And then, so I'm just, this one is,
I think I think another example will help. What do you got? Right, for you, yes. For them, not yet. Okay. Any questions about this besides that one? And I think hopefully it will answer in the next example. Fair enough? If it doesn't, we'll do another one. So I have x minus 1 divided into x cubed plus 5x squared plus 3x minus 4. So where do I start? First terms, right? First term divided by the first term. What is x cubed divided by x? X squared, right? Where does it go? Above the x squared term. Now what do I do? Multiply. What is x squared times x? X cubed. What is x squared times negative 1? Negative 1x squared.
wait, why are you bringing the x cubed in?
I said x squared times x, and that's x cubed.
Oh, okay.
And then I said x squared times negative 1, and that's negative 1x. I'm not just bringing this term down. I'm actually multiplying right here to get that term. Okay? Good question. Now what do I do? Subtract, right? If I subtract this term, I get negative x cubed. If I subtract this term, what do I get? Positive 1x squared, right? So what's x cubed and negative x cubed? Again, is that always going to go to 0? Yes. What about right here? What do I get? 6x squared.
Wait, why are you adding now?
All I did was I'm bringing this term down and bringing this term down.
No,
It's like,
Oh,
because there's negative, and you have to, a negative plus is a negative.
I'm subtracting each term, so I'm changing the sign on each term. And when I subtract, when I change the sign, then I just combine what's there. I combine a 5 and I combine a 1, and I get 6. On this one, when I subtracted, I had a 5 and I had a negative 2. So I'm just combining those two terms to get 3. Okay? Now I start over. First term here, first term here. What's 6x squared divided by x? 6x. I wrote it above the term that it's like. What is 6x times x?
6x squared.
6x squared. What's 6x times negative 1?
Negative 6x.
Negative 6x. I'm subtracting each term. Now I combine. 0. 9x. Whoops. Minus 4. And now I start again. First term. First term. What's 9x divided by x? 9. Good. It's 9 times x. 9x. What's 9 times negative 1? Negative 9. Then I subtract each term, which gives us 5. This one's 0, right? Negative 4 and positive 9 is 5. What does that mean we have this time? A remainder. So plus what? Perfect. 5 over x minus 1. Questions? You feeling better? Is it just the same steps over and over again? It is, right? But how many steps are there? There's lots of little steps, aren't there? Okay, there's lots of little steps. Earlier they said to me, so you're going to tell me tomorrow there's a shortcut to this, right? Well, kinda. But not. It's one of the shortcuts that does not work every time. Which means you've got to know how to do long division. Because the one I'm going to show you tomorrow, I mean, it's not really a shortcut. It's just a different kind of division. But it doesn't work every time. Okay? Don't write this down yet, because there's something wrong with it. I'm going to have to fix it before we can actually do the problem. But I'm going to write it down so you can see what it is. Okay? When we did this problem, what do you notice about the variables and their exponents? They go in order, right? If it starts at x to the third, the next one is x squared, and the next one is x to the first, and the last one is just nothing, right? A constant. What's the problem with this problem then? It's out of order. It's out of order? Or it's missing stuff, right? Is it allowed to be missing stuff?
Yes.
Nope, it's not. Okay? So, the way that it's going to be written in the book is like this. That's how it's going to be written in the book without the division sign. It's going to be written like this. When you write it on your paper, you don't want to waste paper. You want to write it the way it's supposed to be when you write it on your paper. Okay? So, what am I going to be dividing by? 3x squared. If it starts with an x squared, what do I have to have next? An x. Is there an x term over here? What's the only thing I can add that doesn't change the value? 0. 0x. Then minus 4. Is everything underneath the division sign there? What needs to go first? 3x to the fourth, and then 0x cubed. You'll see. I think you'll see why in just a second, I hope. If you don't, ask me again in a minute. Okay? If you don't see why, ask me in a minute. So, I don't want to pay attention to that right there. That was just the problem. Okay? Now I start. What's this divided by this? First term divided by first term. Here and here. Alright, just to help you out. Hopefully you won't have to do this very much longer. What's left? X squared. What's x squared times 3x squared? 3x to the fourth. What's x squared times 0x? 0x to the third. What's x squared times negative 4? What do I do? Subtract every term. If I'm subtracting every term, why is that a positive? Because I'm subtracting a negative, right? Subtracting a negative is adding, isn't it? So here I get what? 0. Here I get what? 0. Here I get what? 9x squared. Good.
Can we write this down now?
Absolutely.
All right.
Sorry. Now what? Start over, right? 9x squared divided by 3x squared. What is that? 3. Positive 3 or negative 3? Positive. So I'm going to put it over here. Why do I have to put it over there? It's above the term that it's like, right? 3 times 3x squared. 9x squared 3 times 0x. 0x, right? What's 3 times negative 4?
Negative 12.
Now what? Subtract. I'm subtracting that term and subtracting that term and subtracting that term. What's that? 0?
0.
6x plus 2. Now what?
Do it again.
Do it again. 6x divided by 3x squared. Uh-oh, right? 6x divided by 3x squared. That cancels, but I still have an x left in the denominator, which means I can't go any further. What is this right here? That's my remainder. So plus what? 6x plus 2 over,
3x squared plus 0x.
and here at this point you can go ahead and just write there. So my answer is that. Questions?
No, ma'am.
Are any of the steps hard?
Oh, yeah.
Then why don't people like this?
Lots of work.
It's time consuming, lots of work. Okay? But here's the deal, like I told you a second ago, tomorrow we're going to be able to do this problem. If you count all the lines on your paper that you used, all the lines on the paper right here was 1, 2, 3, 4, 5, 6, 7, 8, right? Tomorrow we're going to be able to do it in 3 lines. Isn't that going to be nice? I can't do this one that way. I can't. Because the division I'm going to show you tomorrow, you can't do this problem that way. So if I ask you for this problem, you would have to do this with long division. Okay? But you'll see that tomorrow, so don't worry about that. Okay? You have a couple homework problems to get done. Looks like 6. I hope you have a wonderful day.